Greetings, everyone. This is a very brief introduction to CSRF or CSRF and the browser-csrf module, which you can use in your web applications to help thwart CSRF attacks. So, what is a CSRF? OWASP already defines this super well on our behalf. It's an attack that forces an end user to execute unwanted actions on a web application, which they're currently authenticated. It's a little meta, it's a little hard to grok, but essentially a very common vector for this attack is someone exercises social engineering, makes an artificial web page that they guide your vulnerable user to. That vulnerable user goes to that malicious web page, and something on that web page, whether that be through a redirect or some sort of network request, issues a command against your website. And because cookies often are used for authentication and the browser automatically injects cookies into network requests, that malicious site is able to issue a command on behalf of the user. So, that sounds all said and good, but it's still kind of hard to visualize. Henceforth, I've created a basic example that we can walk through here together. So inside the browser CSRF code, we've got two servers. One is malicious, one is vulnerable. They both serve web pages, and the vulnerable one serves a hypothetical vulnerable bank. So let's run it. Yeah. All right, so let's get the malicious server online, source index. Let's get the vulnerable server online, node. Feel free to run these at home as well. Exploit vuln source index. It doesn't show it, but this malicious server, the vulnerable server is serving a website on 7,777. And here we go. We have ourselves a dummy bank that's vulnerable to CSRFs. So I'm going to log in. Admin, as shown here. I click submit, and we are into the bank. So what happened on submission of the login request? Let's just take a quick peek. Come on. Login. There it was. Oh, come on, Chrome. Great. The response headers of that login API request gave us a set cookie. And if we go look in our application in the Chrome tab, we can inspect those cookies to make sure they're there. Great. So let's play with the bank just for a quick sec. So in real life, of course, you're not going to see both my funds and your funds, but this is an example. So suppose I want to transfer funds from me to you. I'm going to type in $1, and I'm going to hit transfer. Great, it transferred over from me to you. Let's transfer $5. Woohoo, you are getting rich. So what's actually happening here? It's making an API call. Let's go inspect that API call. Let's look at the $5 one. So as you can see from the request URI, this is a basic API request. It's happening over GET. Usually these things you're going to do over a POST request, but for ease of example, it's over a GET, and we're transferring from me to you the amount of $5. So why is the server honoring this request? How come it's not rejecting the request? Well, there's a lot of reasons, but the reason I want to focus on is the fact that we're passing an auth cookie, and the server is saying, okay, does this person's auth token exist? Is it valid? Is this a real user that I've authenticated recently? If so, let the transfer happen. If not, reject. Very common mechanism used in web apps. So let's switch gears. Now that we've exercised our site, let's exercise a CSRF against it. Suppose that some malicious actor has created a fake site that they're going to tell you, they say in an email to you that this is a totally safe and friendly site, and it's going to help you change your bank password. You say, oh, okay, it's probably good to change my bank password now. I haven't done it in a couple months. Let's jump on there. So you're going to click that link to the malicious website, and whoa, what happened? What happened was the malicious website issued a redirect back to your website and executed a transfer command. So right from the URI, transfer from me to you $1,000. And it worked. Like, that's the crazy part, right? I went to a completely different website and it just executed a command against our website and transferred money. Good grief. Of course it worked because the redirect, like with all other network requests to your own website, auto-inject that authorization token from the cookie. So if we go back to our vulnerable website, and because I'm a shortcutting web developer, shame on me, we have to relog on, and I can see, sure enough, I'm down $1,000 from where I was a minute ago. Okay, so that's the basic premise of a CSRF attack. How can this module help prevent your website from being vulnerable? Well, two components are needed. One, your server needs to be sniffing for CSRF tokens behind protected routes. So, this transfer route is a protected route. I don't want to let transfers through from just any old redirect. So how can we prevent against that? One way to do it is to keep another token in your website's memory. That way, when your website issues commands against its own API, your API can check that token and make sure that that's a valid token as well. Why is that different than just using the cookie? Well, if it's in our browser's memory, doing a redirect, as we saw here in this vulnerable case, doesn't have access to that memory. So it can inject that into the request, and theoretically, the API will say, nope, I don't see that CSRF token, so I'm not going to let this action take place. So here's what we're going to do. We're going to go to our vulnerable server. We're going to enable CSRF protection. All this does is behind those protected routes, sniffs for that extra header, the CSRF token, and validates that as well as the cookie. So I'm going to run that. The next part is to actually get that CSRF token that our server is going to generate for us and make sure to inject it on every network request from our own app, from our own tab, if that helps. So if I go back to my vulnerable website, which isn't vulnerable anymore, we're going to start calling it the protected website, and I look at the basic JavaScript file entry point into our JavaScript part of our application, I see that we make a login request. After we log on, the response to that logon is going to have a CSRF token. So I'm going to use browser-csrf to inject it into every network request. That's XHRs, that's fetch requests, which are pretty new. And that's even things like form submissions if you're using the browser built-in submission APIs. So that's cool, that's slick. We've enabled it in the browser and we've enabled it on the server. So let's revisit our website and see what happens. I'm going to log back in. And I'm going to open DevTools so we can sniff the network again. And I'm going to transfer from me to you $20 because I'm feeling very generous. And I'm going to go look at that network request. So if I look at the request headers now, you're going to see this new thing, CSRF token. So we sent a CSRF token along with our auth cookie. That's great. It let us through because it was validating on that CSRF token. Let's once again go visit our malicious website. Open new tab. And sure enough, we get a 401 authorized. Why? Well, this evil redirect that tried to issue a command did issue the command, and guess what? It had that auth token from the cookie, but it did not have the CSRF token because it didn't have access to that token that only exists in our local web app's memory. So that's the high level. Hope you enjoyed the video. I hope it makes sense. Feel free to add comments, ask questions, check out the CSRF module, and put in PRs. There's lots of improvements to be made. I look forward to growing it with you. Thanks. Adios.